Assalamualaikum warahmatullahi taala wabarakatuh. I wish to all the viewers, my fellow friends, and especially to my beloved lecturer. I hope everyone in the pink of health. My name is Mohd Aiman bin Zaman, and today my friends and I will present and explain about one of the topic in application of differentiation, which is applied maximum and minimum problems. Apply maximum and minimum problems is to show that the problem given is maximum or minimum by using the first derivative and second derivative. Moreover, the process of finding maximum or minimum values is called optimization. Finding a maximum or minimum has its application in pure mathematics, where, for example, we could find the largest rectangle that has a given perimeter. It also has its application to commercial problems, such as finding the least dimension of a carton that is to contain a given volume. This application is commonly used in occupations such as engineering, scientists, and economists. What is differentiation? Differentiation is a process of finding the derivative of a function that outputs the rate of change of one variable with respect to another variable. This is equivalent to finding the slope of the tangent line to the function at a point. In mathematics, differential calculus is a subfield of calculus that studies the rates at which quantities change. It is one of the two traditional divisions of calculus. The other is integral calculus, which is the study of the area beneath a curve. When do we apply differentiation? As I mentioned before, the main use for differentiation is to find the gradient of a function at any point on the graph. In real life, we use differentiation to calculate the profit and loss in business using graph, check the temperature variation, and determine the speed or distance covered such as miles per hour, kilometer per hour, and others. In differentiation, we also use the derivative to determine the maximum and minimum values of particular functions. The derivative is defined as the rate of change of one quantity with respect to another. In terms of functions, the rate of change of function is defined as derivative of y with respect to x equal to fx equal to y prime. The concept of derivative has been used in small scale and large scale. The concept of derivative used in many ways, such as change of temperature or rate of change of shapes and size of an object depending on the conditions and others. Derivative also has various important applications in mathematics, such as rate of change of quantity, increasing and decreasing functions, tangent and normal to a curve, minimum and maximum values, Newton's method, and linear approximation.
My name is Hazim Fitri, and now I'm going to explain about problem statement. The problem is find the dimension of the least expensive rectangular box that is 3 times as long as it is wide and which hold 100 cubic centimeter of water. The material for the bottom cost is 70 cents per centimeter square. The side cost is 50 cents per centimeter square, and the top is cost 12 cents per centimeter square. From the question, we can the information that we get is rectangular box. So we're going to draw rectangular box, and the length of the rectangular box is 3 times long as it wide. So we draw rectangular box and label its dimension, which is the length is 3 times wide, 3w, and the wide is w and height is h. Then from the question we get the volume of the rectangular box is 100 cubic centimeter of water. The information we get from the question is bottom cost is 70 cents per centimeter square, side cost 50 cents per centimeter square, and top cost 12 cents per centimeter square. So we got bottom cost is 70 cents per centimeter square, side is cost 50 cents per centimeter square, top cost is 12 cents per centimeter square, and the question wants the least expensive dimension of rectangular box, so we must find the cheapest dimension to create the rectangular box.
Hi, Assalamualaikum. My name is Fariz Izzwan bin Muhammad from group PEM 1101D1. Relation for length equal to 3 width. Okay. After that, we should list it like this, which is bottom area is this, and the formula area for bottom area is width times length, which will make it easier for us. So width times length times 17 cent. This 17, 15, 15, 12 is in cent actually, but we write in like this in first because it will be easier for us to calculate the actual length for all of it. Okay. After we write it all like this, we will get the first equation. We cannot differentiate it because there is a three unknown in this equation. So to differentiate it, we need to make it one unknown, which is we will left one unknown, which is the W. So why W? Because the information gave us length equal to 3W. So we sub this into our first equation and we will get this. The question also gave us the volume for rectangular, which is 100, and the formula for volume is width times length times height. So we already have the length, so just substitute first, and then we will get the h like this. After we get this, we substitute this into our first equation like how we did this, and finally we will get only one unknown in our equation, and then we can differentiate it like this. We let our C prime equal to 0 because we just want to find what is the W, the value of W, and then we get our second. After that, we sub our second into this equation and we will get length. And after we get length, we sub our length, we sub our W into this because it will make easier because we already have the W. We can also just substitute length and W into our first equation like this, but since we already have this, just substitute W into this, and then we have all the value for the length, width and height. After that, we sub all width, length and height into our first equation, and then we will get the minimum cost. That's all from me. Thank you.